Hello friends, I am Amir Nizami and today we are going to study the post-processing results from Abaqus file. So just I will start. So we have manually, because last time I have shown you with the Python scripting how we post-process the results using the Python script, and it shows a very good and very handy results. So it was very fast, but somehow few students have asked that, sir, I don't want to write at this time, or I am not much uh, having knowledge of Python, so I want manually to how to uh, choose the points and get the results from there. So that's the post-process results. So I just try to explain that. So here you can see in this image also directly I've shown here the how the deformed plate is there, three-dimensional plate, and how this corresponding to that the displacements U3 and the stress sigma 3 is shown here. So we will see one by one. Okay. So first of all, we know, because I've shown some videos also already made before. So you may go through my YouTube videos from last few 4 or 5 videos back. So you may see here Abaqus higher version, okay, lower version issue, then sinusoidal distributed load, exact three-dimensional elasticity solutions I've shown. Then I've shown how to model it in the Abaqus. So full 34 minutes videos are there. So I've shown completely how to model it, a three-dimensional plate, using the C3D8R or C3D20 R element, and then I've also shown for the thermal analysis. So today we are just going to see how manually we will do it. Okay, so just going back, and yeah, so first of all, I thanks to Dr. Dominic Madia, so who is the founder of FEA Academy, FEA specialist, and have also written the various books for the finite element method. So he helped me. I was having some confusion regarding the transfer shear stresses, and I was not getting the continuous shear stress through this profile. But anyhow, he suggested me a lot of things to do, fine meshing, and also various points he has mentioned. So I will try to do that, and I thanks for that for Dr. Dominic. Thanks a lot. Okay, now let us see. First of all, what we want. We want the post processing, yeah, post processing of the results, post process. So post process mainly we want the results in terms of displacements and the stresses. So we have three displacements: x, y, u of x, y, z, yeah, three-dimensional we have, and which position we want, in plane displacement u at x 0, and y coordinate should be b by 2, yeah, so 0 and b by 2, 0, b by 2, and z coordinate would be throughout from minus h by 2 to plus h by 2. Okay, and at which position we want the displacement along the y direction, or v or u2 we can say. This is, we can say u1, this is, we can say u2, which is v in this, and that what is the coordinate where we want a by 2 comma y coordinate as 0 and z throughout the thickness of the plate. And what is u3? That is the w of the displacement, we say x comma y comma z. What is the coordinate where we want to find this displacement? W we want to find at the center, yeah, so a by 2, b by 2, and throughout the plate thickness. Okay, so this coordinate should be remembered. Okay, because if you will match your results with Pagano's paper or any three-dimensional elasticity paper, Pagano's paper of 1969, okay, bidirectional laminate. So you will find the coordinate for the displacement u, v, w should be provided like this. Okay. Also the stresses now. So let us say sigma xx, sigma yy, and sigma zz. If you want to find these three, you have to find at the center, a by 2, b by 2, and throughout the plate thickness z. Okay. If you want to find sigma xz, sigma yz, yeah, so sigma xz if you want to find, so that should be different. So let me make it separately. Sigma xz, where we want at 0 comma b by 2 comma z, and sigma yz, where we want to find the coordinate is a by 2 0 and then throughout the plate. Okay, so these are the points, and it is very important. Okay, we should know where we want to find. Okay, so if you want to find the in-plane displacement u and you are providing at 0 0 or a by 2 b by 2 at center, you will get the 0 results. Okay, so that's why we should know the points where we are going to find that. Okay, and now we are going to Abaqus file and let us see. Okay, so right now what we are seeing, this plate as undeformed. Yes, it is meshed, but it is undeformed. There is no load. But once the load would be applied, okay, so there would be the deformation. Okay, and how it get deformed, we can see from here. So if we get we can see the deformed shape. Yes. So now if you see this deformed shape, and let me go to it would be much better to go for the displacements. Yeah, and let us say U1. Okay. So you can see here how the zigzag pattern is observed here. Yeah, how the zigzag pattern is observed at this edge. Okay, so if we want to know at which position, so just get here and let us see. Now we can see here after cutting how at the center when we will reach, how this is varying. Yeah, so at the center the warping is 0. Okay, there is no warping is observed at the center of the plate. Okay, so at a by 2 b by 2 you can see here it's 0, but at the edge you can see here how the warping is there. Yeah, zigzag effect. Okay, so if you want to plot the transverse displacement W, okay, U3, so we have to choose the position at a by 2 b by 2. Yes, at the center. So we have to reach at the center. So what we will do, we will do like this. Okay, now we reached at the center, and now we will choose the points. Okay, so there is two ways to choose the point. Okay, so what we do, let's see. So one way, we will choose one by one all the points. So going to tools, then going to path. Okay, and then create. So let us say path 2, or we can say path for U3. Okay, U3 means W displacement. So that is found at the center. So we are just going for that point. Right now, we are just directly manually we will choose the points. So right now I just click it as before, and I will choose here. Okay, so just let us choose the points. Okay, 1, this point. Okay, and finally we reached here, and we have done. Okay, we say okay. We have chosen the points, and now we want to see the plots. Okay, so now we come to the XY data. Hit XY, path is chosen, continue. So the path, what the name we have given, U3. So let us click on U3, and we want throughout the plate thickness. So thickness Z coordinate, and which displacement is performed here. So that should be U3 at the center. Okay, so now we apply here and we see it. Okay, so now we want to plot it. Plot, you see the displacements U3, you can see here. Yeah, so this is the, you can see here U3 displacement Z coordinates, and vertical it is the displacement and the coordinates. So this is shown on the x-axis, it's shown the Z coordinate, any plate thickness, and on the y-axis it is shown the displacement field. Okay, now at this position also what you can find the same coordinate which we have chosen, we have seen just now. Okay, so you just come here, and what we can find out at the same path. So all the center positions A by 2, B by 2, yes, these all stresses sigma xx, sigma yy, sigma zz we can find from there. So let us see. So now we go to this field output, we click here, we go to this stress components at the integration points, and let us click here S11. We apply here and we say okay. Now plot it. Let us see the plot. So this is the sigma xx, what you are getting from here. Yes, and you are getting the exact results. If you will compare it with Pagano's result, you will get the same. Yes, you have to normalize the value. Yeah, corresponding to that, what the normalized values they have taken in that paper. Okay, now we will see sigma 22, that is a sigma yy. So now apply. Okay, plot. So this is the exact what we are having, sigma yy. Okay, and then come back and we will see sigma 33, that is the sigma zz. Okay, let's see. So this is what we are getting, sigma zz from here. Okay, stresses to the plate thickness. So you can see here it is the stress how it is varying. Okay, so throughout the plate thickness. So at the bottom it is 0, and when it reaches the top means 0 to 30. Okay, so 30 is the top thickness. So at that position the coordinate magnitude is stress is -1, means the load is acting in the downward direction. Okay, so that is the case we have seen. Okay, so now if we want to find u1 or u2, then we can't find at this coordinate. Okay, if you will find it, you will see something which is, if you want to find u1, what you will get from there, the u1 in plane displacement or the warping, you may see it is like this. What is the magnitude? You see what is the magnitude? It is -15, means it is almost 0. Yes, -15 is almost 0. Okay, so this is the way, and you can see also u2, so that would be of the same order. Okay, this is also, click here, so this is also like that, -15 magnitude, which is 0. Okay, so now if you want to plot that, let us do in plane displacements. If you want to find, now we will make it complete. So where to choose that point, let us see. So for this is the main x-axis, z-axis and y-axis. So coordinate for the u1. So what is the coordinate for the u1? Let us see what we have chosen. X coordinate should be 0. Y coordinate should be b/2. Okay, now go back, choose here. So x coordinate where? So we know this x is starting from the left edge. So x on this x would be 0 on this, and y should be b/2. So let us come back and we will see at the mid y would be b/2. So now we can choose the point here. You can choose the point here, let us say. So now we will go to tools, go to path, we'll create a new path, and we will say path for which u2. Okay, so that is the v displacements. We will go back, and now we will see another way. Okay, what's the other way of doing that? Either we choose 1 by 1, or we may do another thing. Okay, what is that another thing? You just find the first value of the top value and the bottom value of the nodes. Okay, and then we will insert it. So we can do it in this way. We will cancel it. We first know what's the query and what's the node number. Okay, so just a node. Which node? We want this node. Okay, or this node, anyone which is at the center. Let's do it. This one. What is the node number here? That is 338. So you have to write somewhere this node number. Okay, so take one page and write down the node number. That is what? 338. So 338. Okay, now come to the another, just this one, bottom nodes. Click here. What is that? 242. So you write it 242. Okay, now you get this. Now we go back and tools, go to path, create. What the name we were giving it? u2. So give it u2. continue. Now come here. What's the first point you have chosen? 3, 3, 8. Then put comma. Okay. Then provide 2, 4, 2. 2, 4, 2. Okay. And then you do okay. Now you go to XY data. You go to path, continue. You choose here which path you have chosen. Path U2. Yes. For the V plot. So now we have here, there may be no intersection, so you have to click on include intersection. If you will include intersection, what will happen? You see here, you will see that all the points get connected. Okay. And now you may plot here. So U2 is already chosen. Apply. Okay. Plot. So this is the U2 plot it is showing here. But why it is like this? It should not be. Why is it like this? No, sorry. We have chosen for x0 and yb by 2. Sorry. So that is u1, not u2. We have to correct it. Okay. So we have chosen for the u1 position. So that's wrong. We have to do it. We have to rename it. Okay. Path should be u1. So now we will plot it here. So we will see, yes. You see. This is the zigzag pattern which is observed. Okay. So you can observe from here the zigzag path. Okay. That is the zigzag displacement for the U1. Okay. Now we have the another position. Next is what? At this point, okay, if you choose stress, so which stress at 0 V by 2 means sigma 1 3. Okay. So corresponding to sigma 1 3, if we have, you see, actually we should get the continuous shear stress at the interfaces, but we will get some how the jump. So it is like this what we are getting. Okay, let us do it somehow. Okay, let us choose another path. We go to tools, XY data. No, path, we go create. Let us choose path is which coordinate if we want for the V displacements. V is at which position? V at position. What we have chosen for the V? A by 2 and 0. Okay. So A by 2 and 0 means path we can say V. Let us say we have given the name V. Continue. And now I will choose it here. So first of all, rotate the axis. Okay. So make it first. Okay. So now we will see here. This is our xy. This x equals to a by 2 and y equals to 0. So at this edge, we will see here. So we will choose the data here. Okay. So now let us do it. So if we do it manually, let us choose the manually. So how we will do? Let us choose connect all the points. Okay, it's done. Okay, and then we go to XY data. We go to continue. We go to which point? We have path. As we first point left. Let us see. Okay. Now field output. What we want? We want U2. Apply. Okay. What? So we are getting the plot U2 here. Okay. So this is a very coarse mesh. If you want to get the better results, we have to find it. Okay. So once we find the meshes, we get the better results. And fineness is the compulsory for the any FEA analysis. Okay, so we start with the course one. Once we get that okay, we are getting the good results or the good structure, then what we do, we then find the mesh and we get the convergence of the results. So we can see here, I have done here for the displacements, so you may see. So for various 10 mm size, okay, of the mesh, then I did 5 mm mesh size, then 2.5 mm mesh size, and finally 1 mm mesh size. Okay, so for the in-plane displacements, we saw that okay, if we get with this, we get a good results. But further we see UV, that is the U2 results, that's also fine. But if we go for this, you see, if we take the 10 mm mesh, you see how far it is from the transverse displacement. Yeah. So from the actual one, from the exact 3D Pagano solution, it is much far. Okay. Once we reduce that size, 5 mm, 2.5 mm, it is getting converged. Okay. So the red one which we see, that is a 2.5 mm, that is closer, and you see this blue one, which is 1 mm size, that's exactly matching with the black, means the exact solution. Okay. So the convergence result is compulsory in this finite element analysis. Okay. So that's what we try to do. Okay. So in this, I try to just show how to do it manually and how to extract the results. Okay. And you can also take the data from there. Okay. You can also take the data, store the data from here. Okay. Operate on XY data and just you can get the data. So whatsoever the data, you can here also help to take the plot. Okay. And you have this temp data. You can edit here, and you can copy paste or save it, okay, and use in Excel sheets or any other file, and you can plot it further. Okay, so I'm closing here, and in the next class I will try for the remaining thermal portion, inshallah, to cover. Thank you.